Hey, what's up coders, I'm Coderious and today we are coding a procedurally generated Starfield in Unity. We will see how we can easily create millions of stars without making our hard drive explode. For this we will use a time map, sprites and pseudo-random numbers. In this video we will see how we can create a persistent universe using built-in functions such as the Unity random function. And we have a new guest. So I was saying that we will create a persistent universe using built-in functions such as the Unity random functions, cryptographic functions, this one are just for fun, and Perlin noise. What we will see today resembles a lot of what has been done in the game Star Traders Allied, for instance. In this game we can explore a vast universe and complete thousands of missions. Before we start, take a moment to like and subscribe. I see you in Unity. Let's start with an empty 2D project. As mentioned at the beginning, we will use a tile map and some sprites. So let's first add a tile map to our scene. I used the web app Piscal to draw the stars that we will use in the Starfield. There is a link in the description to download the sprites I made. We can also try out Piscal or just use any sprite. We can then create tiles out of our sprites. First, make sure the texture type of the stars is set to sprite. Open the tile palette window and create a new palette. We can call it stars. Let's save it into a new folder called palettes, and then simply drag and drop the sprites into the palette. We can save the newly created tiles in a new folder called the tiles. Awesome! Our tiles are ready. Space is big, so we better know where we are on the map. For that, let's add some UI elements like the X and the Y coordinates, as well as a button for space travel. We can add a simple TextMesh Pro text for coordinates and input fields, plus a button for navigating. We will code these functionalities later on. Finally, let's also add a nice skybox. In this video I use the Real Star skybox, which is free on the Unity Asset Store. It can then be added in the environment lighting and the camera. Finally, we create a new empty object, rename it Game Manager and add a new C# script with the same name to it. Alright, let's write some code and open the script in Visual Studio. As we are using tile maps, we need to add the related package at the beginning of the script. We also use TextMesh Pro and therefore need the TMPro package. We need a few variables to make this work. Firstly, let's get our grid and tile map. So we create a public grid, call it grid, and a public tile map, call it map. We don't actually need the grid, but I forgot to remove it. We also want a link to our tiles, and for that we can create an array of tiles. In addition to that, we can define the width and the height of the region in space that we want to render. Let's use 16 and 9. We define also the camera speed to control the movement of the camera with a value of 10. The random key as an integer will be used to randomize the universe. Finally, let's have a link to our text boxes to display the coordinates. Okay, let's now create a function to draw stars in our galaxy. We can create a new void function and call it GenerateStars. In there, we will loop through the different tiles of our tile map and decide if a star should exist or not. We will loop around the position of the camera on the tile map, so we need to actually translate the position of the camera on the tile map. Tile positions are stored in vector3int, so to find the position of the camera we can use the function world2cell from the tile map, and give the position of the camera as parameter. At this stage we can also display the position of the camera on our user interface. We pass the X and the Y values to the text boxes. Let's try this quickly and see if it works. Okay, seems to be the case. The values are updated when we move the camera. Great! So we can now create a double loop around the position of the camera. We loop from X as the position of the camera minus the width to the position of the camera plus the width. We do the same with the Y and the height and keep track of the current position in the vector3 int. To decide whether a star should appear or not, we can just use a random number between 0 and 10 and draw a star if the result is 0. The first number is included, whereas the last is not when using random range with integers. So here we will actually get a number between 0 and 9, so that's a 10% probability of having a 0. To decide which star is drawn, we can do about the same and select a random star from our tile array. We call the setTile function, pass on the position we calculated earlier and give a random range value between 0 and the size of our tile array. Let's call the function in the update method and try. Okay, not really what we wanted. Stars are generated each frame and it becomes rapidly messy. Let's put the generate stars function in the start method instead. Alright, that's already better. Our stars are showing up and it looks like it's random. But there is just one problem. If we stop the program and run it again, the universe is not the same. How could we turn this in a persistent universe? We can achieve that using a seed. The seed will ensure that the random sequence is the same each time we call random functions. So it's not totally random as you guessed, and that's why we call these random numbers pseudo-random numbers. We can seed the Unity random class with the initState method and use the random key we defined earlier. Let's try again. Note this part of the screen. Now we stop the game and start again. And yep, this is the same universe. If we change the key, close the program and run again, it's the same universe, but different from the one before as the seed is different. It looks great, but it won't be that easy. We still have some issues to solve. Let's code some commands to move the camera around. First, let's get the transform of the main camera. And in the update method, we can check for an input on the vertical and horizontal axis. In case of an input, we'll up the camera using the right vector on the horizontal axis and up vector on the vertical axis. After having adjusted the position, we clear the tiles and generate the stars again. Okay, let's try. Well, it looks like we have lost our persistence. Each time we move, a new set of stars is generated, and that's because we call the random function on another random part of the universe. To maintain persistence, we must ensure that each tile location is handled individually by the pseudo-random number generator. For that we could use the coordinate of the tile as a seed, as it's unique for each tile. But well, the seed is an integer, and the coordinate values are an x and y. So how could we turn them into a single value? We will look at three options to generate a seed based on the x and the y coordinate. We could for instance use the shift operator and somehow squeeze the x and the y in a single value. Let's try that, but first we can remove the init state in the start function. What we do here is shifting the 16 first bits of the y and use the logical OR operator with x. That way, we create a new integer that is almost unique to the x and the y. We can also add our random key for more variation. This method is quite simple but provides interesting results. Let's try. Looks like it's working, but there is just one problem with this method. If we scroll to the left a little bit more, we will see that our universe is not that infinite, or at least the procedural generation is no longer random. Same goes if we increase the value too much. But even if the playfield is a square with a side of 50,000 cells, that's about 2.5 billion potential stars. That should still be quite a lot to play with. Okay, to improve the navigation, let's add a fast travel function to test our universe. We already have the buttons, so let's create a new C# script and open it in Visual Studio. Let's add the TextMesh Pro package to render the UI elements. From there, we just need to read the values from the input fields and convert them to integers. For that, we can use the int.parse function on the x and the y text values. The result goes then as the new position of our main camera, keeping the existing z value. I won't code the error handling, but it would be good to make sure the player enters only numbers in this field. Okay, now we just have to link this function to the button using the event system. In the Unity interface, we can link the newly created function by adding an event on the on-click panel of the button. Drag and drop the canva and select the goto function in there. Drag and drop the input fields in the script and let's give it a try. Okay, that's alright, but we see that beside the number limit, there is also a performance limit. The problem is that going up in the numbers of the coordinates has a significant impact on the performance. While the system is running fine in low coordinate numbers, I mean by that it's running at hundreds of frames per second, it is still barely playable at coordinate of 50,000 for the x and the y, but it starts really slowing down the further we go in space. Let's look at another way to generate a seed. This method is called the contour pairing function. Pairing functions are widely covered in mathematics, and the advantage of this one is that it's very easy to implement and provides a real unique number for x and y. The function is the following. We take the half of the x plus y multiplied by x plus y plus 1 plus y. There are links in the description if you want to know more about it. This function is meant to work only with natural numbers, i.e. the positive integers from 0 to infinity. In practice we see some results for the negative numbers as well, but we also limited if we go further than 30,000, like 40,000 and 40,000 for the x and the y. Performance-wise, it seems to be acceptable as long as we remain within small numbers. Next method is probably an overshoot, but I came up with this while researching the topic and wanted to show it here. For the story, I built a crypto exchange on the Ethereum blockchain a couple of years ago. There is still a demo available on my homepage if you want to have a look. If you guys are interested about it, let me know in the comment section and I might make a video about it. Blockchains use very complex cryptographic functions to secure entire networks. One of the encrypting functions used on the Ethereum blockchain is the SHA-3 hash function. It takes any sort of input like a byte array or a string and returns an almost unique 256-bit value. To do this we will need to import few more packages. First the cryptography package from system.security and the system.text package. First we create a new SHA-256 object and we then compute the hash code of the x plus y passed on as a string and encoded to ASCII. We convert this byte array into a string using the bit converter, make some formatting adjustments, and finally convert this hexadecimal number to a big integer. Okay, no worries if it seems a bit complicated. At the end, what's important is that we have a unique identifier for x and y coordinates, and that big integer is quite unique to the x and the y. We can't use big integers as a seed as it would overflow the int value, so instead we can just use a modulo of that number. Let's take for instance the modulo 5 and draw a star when the result is 0. To define which star is drawn, I had to try a bit. I realized that the result of the hash function is not normally distributed. Some stars were just not appearing by taking only the modulo 6. So I took the modulo 36 and divided the result by 6 to have a more homogeneous result. Okay, let's give it a try. Alright, our universe is being generated, and a big plus of using a hash function is that there is no limitation in the size of the universe. We could generate trillions of stars. However, returning the hash code of a very big number consumes a lot of resources, so if you don't want to blow up your CPU, you better keep these values to below 100,000 if you run the hash code in your update function. At the end, I think this option is quite interesting if the procedural generation does not need to be done in real time. Alright, let's look at our last option, Perlin noise. Perlin noise is a procedural texture generator that produces a gradient noise. It is well integrated in the Unity math class. It is extensively used in games, and as there are plenty of tutorials about it on YouTube, I won't go into much detail about how it works in this video. The Perlin noise function returns a float between 0 and 1 for a given x and y value. We start by adding a scale variable to our code to control the noise. We divide our x and y by the width and height of the rendered portion of the screen and multiply it by the scale. As we need an integer for the seed, let's multiply the returned Perlin value by 10 million. We then round the result to an integer. We can finally seed our random function with the calculated value. Alright, let's try this. Great, it's very smooth and we can control the shape with the scale and scroll left and right. It goes easily between minus 100,000 to plus 100,000 and starts slowing down only thereafter. Well, if you watched my previous video, this function is probably a good candidate for a multi-threaded job. Perlin noise is a great procedural tool and can be used in many ways. Possibilities are endless. Alright, it's already the end of this video, I hope you enjoyed it. Before going, I wanted to credit Javidix9, also known as the one-on coder, for the concept behind this video. He kindly let me do a port of his original C++ code to Unity. Have a look at his channel, it's full of awesome videos. And before going, take a moment to share, like and subscribe. See you next time!